Hello students, in last session chapter number 3 a pair of linear equations in two variable is completed. Now we see the chapter number 7 coordinate geometry. Coordinate geometry is a interesting and very easy chapter. First of all, coordinate geometry depends on a geometry. We know the coordinates of point lies on a x-axis and the coordinates of point lies on a y-axis. Started from there. Coordinates of point lies on x-axis is of the form x0, then coordinates of point lies on y-axis is of the form 0y. Always a point lies on a x-axis, the y coordinate is 0, and the point lies on a y-axis, the x coordinate is always 0. They are in form of x0 and 0y respectively. The points lies on a x-axis and the y-axis. Now we see the distance between 2 points on a x-axis and on a y-axis. Distance between 2 points lies on x-axis. For that we draw one figure. As we know, x-axis and y-axis divide the plane into 4 quadrants: first, second, third and fourth. X dash, y dash, and origin O. Let 2 points lies on a x-axis. Suppose P x10 and Q x20. The distance between 2 points P and Q is denoted by PQ. Let P x10 and Q x20 are points lies on x-axis. Therefore, distance between P and Q, points P and Q, is denoted by PQ or dPQ. As we know, distance, D for distance, distance between PQ, symbolic form written as PQ or dPQ. The distance between these 2 points PQ is equals to mod difference of the x coordinate, x1 minus x2. Or you can also write PQ is equals to mod x2 minus x1 is also true. It is a distance between 2 points lies on a x-axis. Same way the distance between 2 points lies on a y-axis. Distance between 2 points lies on y-axis. Let's draw one figure. X dash, y y dash and the origin O. Now the 2 points lies on a y-axis. Let us take 2 points A 0 y1 and B 0 y2. The distance between these 2 points from A to B is denoted by AB or DAB as P and Q. Let A 0 y1 and B 0 y2 are the points lies on y-axis. Therefore, distance between point A and B, AB is equals to, again in mode, but the difference of their y coordinates y1 minus y2. Or you can also write AB is equals to, in mode, y2 minus y1. Both are same, the values are same. It just a distance between point lies on x-axis and lies on y-axis. But in our chapter coordinate geometry, first topic is a distance formula. Distance between 2 points lies in any of the quadrants or on a axis, etc., etc. Now we see the distance formula related to our chapter coordinate geometry. Distance formula. It is important, so that keep in mind. Let A, B, P, Q, X, Y take any 2 points. Let A x1 y1 and B x2 y2 are 2 points. Then distance between two points is AB. Distance is written as AB. Now, to find the distance between any 2 points, the 2 points lies in any of the quadrant like this. X dash, suppose P lies in second quadrant, x1 y1, and Q lies in fourth quadrant, Q x2 comma y2. We need to find distance between these 2 points, P to Q. Distance formula is used to find the distance between 2 points. Now how to find the distance? First of all, AB is the distance between 2 points, not a AB square. Square of the difference of their x coordinates, x1 minus x2 whole square, compulsory, plus difference, square of the difference of their y coordinates, y1 minus y2 whole square, and take the square root of it. It is called the distance formula. Or you can also write in this form. AB square is equals to, remove the square root and we get x1 minus x2 whole square plus y1 minus y2 whole square. We remember the second type, AB square is equals to x1 minus x2 whole square, compulsory, plus y1 minus y2 whole square. It is easy to use and easy to remember, but keep in mind AB is the distance. Or you can also write these two formulas in this form. AB square is equals to, instead of x1 minus x2 you have to take x2 minus x1, x2 minus x1 whole square plus y2 minus y1 whole square. Or the AB is equals to square root of x2 minus x1 whole square plus y2 minus y1 whole square. But keep in mind any of the given 2, keep in mind in form of word, take the square of the difference of their x coordinate compulsory plus the square of the difference of their y coordinates, solve it and find out the square root, and we get the distance between these 2 points. Now keep in mind distance between origin and P xy. As we know, the origin has a coordinate 0, 0, then the distance between P xy and O means origin 0, 0. PQ is the distance, but first we take PQ square. Square of the difference of their x coordinate, x minus 0 whole square, compulsory plus square of the difference of their y coordinates. PQ square is equals to x minus 0 whole square gives x square plus y square. Therefore, PQ is equals to square root of x square plus y square. It is a distance between origin and the point lies on any quadrant. It is just a basic information about coordinate geometry. Distance between the points lies on x-axis, distance between 2 points lies on a y-axis, and the distance between any 2 points lies in any quadrant. Now we see some notes regarding this one. Now we see some notes regarding examples and our exercise. Note: first, distance between 2 points distance between 2 points A and B is AB greater than or is equals to 0. Distance can't be negative, it is always 0 or greater than 0. Greater than or is equals to 0, keep in mind. The second one, if A is equals to B, then AB is equals to 0. Now A is equals to B denotes that 2 points are equal. The coordinates of point A is 2, 3, then B has also 2, 3. Then the distance between these 2 points is always 0. Then third one, if the 3 points are collinear. Collinear means the 3 points lies on a straight line like this, A, B and C. As we know, AB plus BC gives us AC. That's why 3 points are collinear. It is conditioned to be 3 points are collinear or not. It is the most important note. If 3 points A, B and C are collinear, then AB plus BC is equals to AC. There will be change in condition if C lies between A and B, then written as AC plus BC is equals to AB. It depends on our coordinates given in the question. And from this one, AC is here, the B lies between the point A and C. B lies between A and C. It is the most important. In this one, the condition will be written as AC plus BC is equals to AB, and the point C lies between A and B from the symbolic notation. Now we discussed one note about the triangles. Fourth, if A x1 y1, B x2 y2 and C x3 y3 are coordinates of triangle ABC, then we know there are lots of types of triangle. In this one we have to take three vertices of triangle. The A is x1 y1, the coordinates of point B is x2 y2, and the coordinates of point 3 is x3 y3. Different types of triangle, in which the equilateral triangle, isosceles triangle, scalene triangle, right triangle, isosceles right triangle, etc., etc. And it has somewhat the characteristic. Using the characteristic, we know the vertices of triangle. We define using the characteristic which type of triangle this vertex is made up. The first is for the equilateral triangle. As we know, the equilateral triangle has three same sides. If AB is equals to BC is equals to AC, then triangle ABC is equilateral triangle. The second one is for isosceles triangle. Isosceles triangle means the two sides are equal and third is not. If AB is equals to BC, two sides are equal but does not equals to third side AC, then triangle ABC is isosceles triangle. If three of sides does not equals to each other, if AB does not equals to BC, does not equals to AC, then triangle ABC is scalene triangle. None of this side is not equal. Then the fourth is for a right triangle. As we know, in right triangle one angle is a 90 degree. AC is called the hypotenuse, and AB and BC are two sides intersect each other at right angle. As we know the Pythagoras theorem here, AC square is equals to AB square plus BC square. If this condition will be defined in triangle, then the triangle is a right triangle. If AB square plus BC square is equals to AC square, square of hypotenuse is equals to sum of the squares of another two sides, it is called Pythagoras theorem, then triangle ABC is right triangle. Now we add two conditions. One is isosceles and a right triangle. Fifth number, if AB is equals to BC and the Pythagoras theorem, two sides are equal. If AB is equals to BC, two sides equal, it is called isosceles triangle. But also the angle B is right angle, it also a right triangle. Mix up it and we get isosceles right triangle. AB is equals to BC and AB square plus BC square is equals to AC square. In this condition we can't write AC square plus BC square is equals to AB square, because two sides are equal, they are a smaller side other than the hypotenuse. Then the triangle ABC is isosceles right triangle. These 5 points remember for the which type of triangle will be made from the given vertices. Very easy thing, keep in mind in form of words. Now we discussed for the quadrilateral. The fifth point, if the 4 vertices are given, we don't know which type of quadrilateral given here, but quadrilateral has a 4 vertices. Suppose A, x1, y1, B, x2, y2, C, x3, y3, and D, x4, y4. As we know, also the quadrilateral having a characteristic, different types of characteristic. If or let A, x1, y1, B, x2, y2, comma, C, x3, y3, and D, x4, y4 are the coordinates of quadrilateral A, B, C, D. Then we discussed here 4 types of quadrilateral, in which first is rhombus, then square, then parallelogram, and a rectangle. Rhombus, in which the 4 sides are equal, 2 diagonals does not equal. We need to find distance formula at least 4 times. If the 4 sides AB is equals to BC is equals to CD is equals to AD. Rhombus is like this. 4 sides are equal, then the quadrilateral will become a rhombus. Then small square is the symbol of quadrilateral, or you can also write in a word. Then quadrilateral ABCD is rhombus. Second one, from the rhombus we obtain a square. In a square, 4 sides equal, both diagonals are also equal. Then write like this: if 4 sides AB is equals to BC is equals to CD and is equals to AD, and the two diagonals are AC and BD in the square. AC is equals to BD, then quadrilateral ABCD is square, means the given vertices are of square. Now remaining two, parallelogram and rectangle. Suppose it is a parallelogram, then opposite sides are equal, diagonals does not equal, then the condition is opposite sides are equal. AB is equals to CD and AD is equals to BC, then it will a parallelogram. Third number, if the opposite side AB is equals to CD and pair of another two sides AD is equals to BC, then quadrilateral ABCD is parallelogram. Now through the parallelogram, condition for a rectangle, as we know, for a rectangle opposite sides are equal. Suppose A, B, C and D. The opposite sides are equal and both diagonals are also equal. It is a condition for a quadrilateral become a rectangle. If AB is equals to CD, AD is equals to BD, and four sides and the two diagonals, and AC is equals to BD, then quadrilateral ABCD is rectangle. Again, the most important thing is for a parallelogram, if the midpoints of both the diagonals are equal, it is called also a parallelogram, but it is not useful in our exercise 7.1. You know the characteristic very well. Keep in mind, this is not for a linear points, collinear points. It is the most important condition. And for the triangle and for the quadrilateral, keep in mind the characteristic. Name will be changed. Here we are taking triangle ABC, you should take triangle PQR, triangle XYZ, etc., etc. Now we see one example to find distance between these 2 points. Find the distance between let us take 2 points, suppose 4, 5 and 1, 1. We need to find distance between these 2 points. First of all, write the given points and give them name. Given points, suppose A is 4, 5 and B is 1, 1. Write like this, not in a same line. We need to find distance between A and B. AB is the distance, but first we need to find AB square. Why AB square? In each and every step we don't write a square root, square root, square root. That's why instead of AB, first we need to find AB square, and at last we find the square root of a number. Keep in mind in word form, take the difference of x coordinate 4 minus 1 whole square, compulsory plus difference of y coordinates 5 minus 1 whole square, square of the difference of their x coordinates, compulsory plus square of the difference of their y coordinates. Here we don't use x1 minus x2 whole square plus y1 minus y2 whole square in each and every sum, because suppose the question says that show that the points are of a rectangle, we use a 6 time distance formula. It is a very conjuncted to each and every time write our distance formula, so that write directly in this form. Now we solve it. 4 minus 1 is a 3 square, compulsory plus 5 minus 1 is a 4 square, 3 square is a 9, 4 square is a 16, 16 plus 9 is a 25. AB square is equals to 25. Keep in mind, AB square is not distance. Distance between 2 points is only AB. Find the square root. AB is equals to square root of 25 is 5. But actually the square root of 25 is plus or minus 5. It is a distance. As we discussed in first note, distance is always greater than or is equals to 0. We can't take here minus 5. Distance can't be negative. That's why AB is equals to 5. It is a distance between 2 points. Now our examples and exercise depend on this, the distance formula. So how to apply distance formula? For that we have to take another sum. Show that 0 minus 3, 1 minus 1, 2, 1 are collinear points. Collinear points means they make a one straight line, they lies on a single line. First of all, write the given equation, given points A 0 minus 3, B 1 minus 1, C 2 1. If the 3 points are collinear, then compulsory this condition will be happened. AB plus BC is equals to AC, or AB plus AC is equals to BC, or BC plus AC is equals to AB. Sum of any two is equals to third one. To find AB, BC and AC, we need to use distance formula 3 times. First, AB square is equals to, AB square is equals to, first of all take the difference of their x coordinates 0 minus 1. If you don't able to write minus form directly, use a square bracket 0 minus 1 whole square. Here no requirement of a square bracket. Compulsory plus, then take the difference of y coordinates. Here is a minus 3. Compulsory minus, it is a minus 1, then put it into bracket, then make a square bracket and whole square. But it is not required. Keep in mind the next one. See how. Difference of x coordinate and square, compulsory plus difference of these 2 points, minus 3, compulsory minus, it is minus 1, the minus become a plus 1 because minus minus plus 1. It is simplified form of our square bracket. First step is not useful and not compulsory. 0 minus 1, which is minus 1 square, plus minus 3 plus 1 is equals to minus 2 square. Minus 1 square is equals to 1 plus minus 2 square is equals to 4. 4 plus 1 is a 5. AB square is equals to 5. That's why AB is equals to root 5. Here AB is equals to root 5. Same way we are using distance formula again 2 times and find BC and AC. BC square is equals to, first of all take the difference of x coordinates 1 2 1 minus 2 whole square. Compulsory plus and the difference between the y coordinates minus 1. It is a 1, it gives minus 1 whole square. 1 minus 2 minus 1 square plus minus 1 minus 2 square. Minus 1 square is equals to 1, minus 2 square is equals to 4. Now 1 plus 4 is again root 5. First 5, then we take root 5. Is equals to 5 BC square. If BC square is equals to 5, then BC is equals to root 5. Same way we need to find AC square. AC square, difference of the x coordinates 0 minus 2 whole square, compulsory plus difference of y coordinates minus 3 and minus 1 whole square. Minus 2 is as it is, minus 3 minus 1 minus 4 square. Minus 2 square is 4 and minus 4 square is 16. 16 plus 4 is 20. Here AC square is equals to 20. Here AC square is 20. Therefore AC is equals to, find the square root. Instead of 20, 4 5s are, square root of 4 is 2. And root 5. AC is equals to 2 root 5. Here rest the greatest part, means root 5 and root 5 are smaller. 2 root 5 is larger than root 5 and root 5. See, the addition of root 5 and root 5 gives 2 root 5. Then write like this. Here AB plus BC, where AB is equals to root 5 and BC is also root 5. Root 5 plus root 5 gives 2 root 5. Now 2 root 5 is the value of AC is equals to AC. Therefore AB plus BC is equals to AC. Hence Hence, given points are collinear. It is an example for a collinear points. If addition of 2 gives a third number, then the points are collinear. If not, then they are not a collinear points and it make a triangle. Okay, one note again, keep in mind, if AB plus BC does not equals to AC, then 3 points are of the triangle and it will make a triangle, as we know. AB plus BC does not equals to AC, then 3 points are non-collinear points and it make a triangle. Include in your one note. In next session, we discuss our examples related to our textbook.